Welcome to ScalaUA conference.
Meta programming in general, and I'm an author of Scala library. If you ever heard about it, no, it's okay. So originally I was planning to talk more about ScalaMeta, but apparently author of ScalaMeta is here, so he's gonna do this job much better. So I'm gonna concentrate more on Scala future, where we're going, and shiny new things in Scala. So okay, currently we have 2.12. I hope everyone is on 2.12 already. No? Yeah? And we're moving forward to 2.13, right? So what's gonna be next? What's gonna be there? As we all know, Scala has a history of having problems with backward compatibility, and finally it was solved starting from 2.10, I believe, right? So now things are much better. So problem solved. So for the future, what guys are going to do, hopefully, is just improve libraries, improve APIs, and hopefully not break things drastically. So, in Scala 2.13, one of the ideas and plans is to modularize Scala library more. You should already know that this work is being done. So if you try to use parser combinators, currently you need to add another library. You know, it was modularized into Scala parser combinators jar. So another thing is this new Dotty thing, which is kind of Scala 3 or not. Even Martin Adersky still doesn't know. But really, I think it's gonna be the next Scala. It's just many years of research. It's gonna be somewhere. So we're gonna talk about it a bit later. There is another backend. So we all know that Scala compiles to a JVM. And also there is a Scala.js backend that compiles Scala to JavaScript, which is very powerful. And now Scala goes native. So we're gonna have a executables, native executables. I'm gonna talk about this later. And there is ScalaMeta, which is, you know, gonna be presented by Zhenya. So the next thing is, currently Scala library is about 5.5 megabytes of size, which is, well, is okay, but we want to do better, right? So the idea for the next versions of Scala is to separate it into libraries like Scala Core and Scala Platform, where Scala Core gonna include like the most essential things like I don't know, tuples and collections. There is a rework started on collections. I'm gonna talk about a bit later. So who knows who this guy is? Not much. This is Paul Phillips, and he's one of the largest contributors to Scala compiler and Scala libraries and collections and whatever. He did a great talk called Scala Collections, Why Not? Actually, it's not a talk, but more a rant. He was describing a lot of Scala library corner cases and Scala typer corner cases on these complexities, and he even resigned from working on compiler, but Zhenya says he still works there. Anyway. So this guy actually pointed out a lot of problems in Scala collections and a lot of and in current compiler. So there is currently work of rewriting implementation of Scala collections, and as of yesterday there was 4 kind of Stroman collection implementations, number 1, 4, 5, and 6. I don't know why. Basically, collections were started from 2.9, I believe, were designed in a way to show the power of mixins. So every collection is a huge mixing of traits. As we know, Scala collections have like 4 separate dimensions. So we have mutable and immutable collections. We have parallel and sequential collections, right? We have lazy and strict collections, like views and normal collections. Also, like these indexed linear sequences, all this combined. Who tried to implement a Scala collection class, like map? Did you enjoy it? So basically, this may look like this. It's a current HashMap implementation, mutable HashMap. So it's a mutable abstract map, which is map-like, which is parallelizable. Yeah. And it extends mutable abstract map, map-like, which extends this map-like, which looks like this. So if you try to figure out how all this works, it's quite complicated. So the idea is to simplify these things, hopefully. Dotty, what's that and why? Current Scala has several problems. One of those is it has very powerful, huge type system which is unsound, which is quite ironic. So there are languages which are based on a good, like theoretical background, like system-F based type systems or Hindley-Milner type systems or whatever is mathematically proved to be sound. Scala was a result of research trying to merge functional programming and object-oriented programming. And as a result, one of the examples is that due to a bug in a type system, Scala type system became Turing complete, which is most of shapeless libraries based on. So this is a problem. We all know that Scala is developed in the university by Martin Andersky, who's a professor there. So it's kind of logical for a type system of Scala to be sound and proven. That's actually what is done in Dotty. Also, there is a binary compatibility problems, which kind of solved, but as a library developer, you have to release your code like for several different versions of Scala. If you try to hack in a compiler, it was told before by in 50 Shades of Compiler. It's quite difficult. It has a lot of mutable state in the compiler, which makes it fast, but it's very hard to reason about it. And it, anyways, compiles quite slowly. So there is a problem. Also, there is a specialization problem. Who knows what specialization is? And okay, some of you. Okay, I'm gonna talk about this a bit later with more details. So, what is And what is Dotty? Dotty is a new compiler for kind of Scala, which is based on this dot calculus, which is dependent object types calculus. This is a foundation of Scala. Finally, previous year, Martin published a paper describing this calculus. What is this, and what's all this about? Basically, it's a small subset of primitives and rules, which look like this, that form a type system of this next Scala. Martin used this program language called Coq, if you ever heard it. It's a dependently typed language and proof assistant. And it can check logical implications, all this kind of stuff. All these kind of things it can prove to be valid and so on. So currently Dotty relies on this proven background, like Haskell or ML. It relies on Hindley-Milner, which is good. All these strange things can be seen in Scala by these kind of primitives, and these primitives are enough to express almost everything in modern Scala. So it's easy to reason about things using this small subset. So what new features does Dotty contain? It has an intersection types, which is like T and U. It's quite similar to T with U, but it is commutative. So if you know how this T with U works, it's due to linearization, it becomes a T is a subtype of U, and it cannot be used in a different order because all the things are gonna blow up. So there are union types which look like this, T or U, which is commutative too. Finally, we have trait parameters. So traits now look like this with kind of arguments, parameters. We have these static annotations on methods and fields, which become Java static. So if you don't know, if you have an object with fields and methods, those are not static. It's just a singleton instance of a class with fields and methods. So it looks like this and compiles to JVM static methods. Also, it's a shame that Scala still has this Java legacy of having equals, using equals that receives object as an argument. Like, it's very non-type safe. So Dotty solves this problem. So operations like equals, equals, and not equals are now type safe. And there are named type parameters. So we have map, you can name type parameters, and for example use it as a named argument, and also you can make it default as far as I understand. So let's take a look into intersection types. Say we have trait A and B, both have type T. If we have A with B, A becomes a subtype of B, and it overrides type T and it becomes int. In case of intersection types, we have intersection of types T from A and B, and get intersection of int and double. Similar thing with union types. So if we have three classes with axis. A and B have the same type, this int. A and C have different types of axes. So we have the union of those. Very nice. And also it gives a possibility to create a very nice enums. So we can have different objects for, say, weekdays. And we can have a type alias of union of types of Saturday and Sunday, for example. Let's take a quick look into internals of Dotty. So Scala C is, who knows what's cake pattern is in Scala? Well, almost everyone. Okay, good. So it's kind of dependency injection, type-safe dependency injection. But Scala C is a huge cake which combines a lot of traits. And when you try to modularize it and separate some functionality, it's very hard because of the transitive dependencies. So Dotty is a full rewrite, and it's not that big a cake. It's simpler to develop. So it has this concept of contexts instead of mutable state, which simplifies development of a compiler significantly. Also, currently Scala C has about 30 phases, right? Which takes a lot of time to execute. So what Dotty does, it introduces this concept of mini phases, which can be run in one run, in one traversal, which make quite good difference. So currently Dotty compiles around twice as fast as Scala C. So if you take a look at high-level architecture Martin published in his talk, Dotty and Scala C look quite the same, except for this tasty thing. So I'm going to talk about it a bit. So we have this problem of publishing the same library for different Scala versions. Let's say we want to support to 10, to 11, to 12, and we have different backends. Scala 6, Scala 8, Scala JS, maybe native. So if you multiply, you'll see how many libraries you have to publish and possibly support. So what's tasty is typed ASTs, right? Kind of. So it's a new AST for Scala code coming from ScalaMeta, which kind of contains Scala representation of your program, but it can be restored. It also contains all the commands, indentations, all that stuff, which can be used by other tools. So it has trees, types, positions, and something else. That means that you can possibly reflect on others' libraries. So you have code, and you can reflect on others' code. You can push a single artifact to Maven that contains the tasty. Only one. And Dotty can recompile, using this tasty, it can recompile that code under your version of compiler and under your backend, which simplifies things a lot. And also it allows full program optimizations. We're going to talk a bit later. So there is a project Dotty Linker by Dima Petrashko. This is a very interesting piece of software which allows to do some very smart things. Smart specialization death code elimination, and can convert classes to value classes, eliminate virtual dispatch sometimes, and even do off-heap memory allocations, but it's there's a demo of that. So how does it, what's the specialization and what's the problem actually? So as you all know, Java has a special separation of primitive types and referential types. And there is a restriction of, you can't use your primitive types as a type argument. So every time you use any collection or any class that has a generic argument, you can't pass int there. There is boxing involved that boxes your int or any primitive to a reference type, which can drastically reduce performance. I'm going to talk a bit later why. To avoid this, this specialization thing was invented. So basically, if you take a look at tuple, it has two arguments, 1 and 2, and it is specialized for these 5 types. What's going to be done is this is going to generate a constructor or a class for each version of this type. We have 2 arguments, 5 types, so we end up with 25 specialized implementations. So if you take a look at tuple 3, it's not specialized, because it's going to be 125 specializations, which blows up your libraries and Scala library, whatever library, very quickly. So what Dotty Linker can do, it can analyze all of your program, can see which actual types you use. For example, you only use tuple 2 with doubles, and it's going to generate only doubles. It's going to reduce a lot of boilerplate. All this power comes in price. There are dropped features in Dotty. Macros. When I first saw this, I was, what? But it's actually, they're dropping reflection-based macros. I'm gonna show you later. Existential types in this form. Who used this for some type ever? Not so much, right? General type projection. So you have general type T, and you project on X. It's unsound. So it's going to be removed, kind of substituted with other thing. All these early initializers, delayed inits for traits, who used those? Not so much. These kind of things, when you early initialize X, this weird syntax, all those are gone because now we have traits parameters. And procedure syntax, if you remember, we can write this. Now, for consistency, there's going to be only one syntax, which is good. Okay, Scala Native, what's that? It's another backend. Instant startup. Who knows about warm-up, interpretation mode in Java, and G compilation? Everyone. So, it looks like this. So we want instant startup. Also, who used JNI? Kind of pain in the ass, right? So we want an easy interop with native code, and we want performance. We want stack allocations, we want manual memory management, we want structs. Java, I believe, the last virtual machine that don't have value classes, right, and structs. CLR has it from the very beginning. Why is it important? So imagine you have your domain, some structure of your domain's data, which is, well, okay. So we get used to not care too much about how our data structures aligned and work, because Java most of the time handles it for us and also manages memory, and that's all fine. The problem is that we live in this world, that we have a memory and this cache. And cache works in this funny way that it loads data and caches data not by single byte. It loads a whole cache line of bytes aligned near the byte you want to get. Basically that means, so if your data is scattered across the memory, which happens quite fast if you, especially when you use immutable data types, which copy things and copy paths. It's not that copy causes problem, it's the memory scattering, which is not very good. Because you're loading a lot of these cache lines with small amounts of data, which makes a lot of cache misses and drastically removes performance. So reading from a cache line, from a cache memory takes about half a nanosecond. Reading from main memory, 100. That makes huge difference. So if you want a performance, and for example, what's the most functional language, programming language you know, on the top of your head? Husky. Okay, so there is this shootout games you probably know, right? So there is a game called N-Body. It's basically crunching doubles, a lot of multiplications and summing of doubles. This is a Haskell solution for this code. So this gives you a hint. So there are some foreign pointers, and there is an ugly Haskell code, which basically does pick element of and poke, which actually is working with arrays, mutating memory and all that stuff. Because if you really want performance, you need arrays. So how can we get it in Scala? LLVM. Who knows what LLVM is?
Kind of low-level virtual machine or something like that.
Yep.
And Scala Native actually uses it.
Yep. So LLVM is an acronym for low-level virtual machine, which has nothing to do with virtual machines actually. It's a project started in the University of Illinois, like a research project for C and C++ backend compiler rewrite. And it's a good project, and most of the modern languages are based on LLVM. Rust, Swift, Julia, Haskell has a backend of LLVM. Scala too. So why? It's quite mature, it's version 4. It supports multiple platforms, just to name a few. It has a lot of optimizations built in. So it has a tail call optimization. Just so you know, Java virtual machine doesn't have a tail call optimization still. Global value numbering, which is just fancy word for constant folding. It also has a just-in-time compiler, so we can do a REPL, and has quite good infrastructure, debugger, etc. It generates, well, Scala Native actually as a final result generates this kind of LLVM assembly, which looks kind of like assembly, and then using a compiler it generates a final machine code. So it's taken from actually Scala Native output. So what you're gonna get with Scala Native? You can use manual memory management, so you can use C, malloc, realloc, free, all that stuff if you like, or Apache runtime, portable runtime, memory pools, whatever you like. You still have a garbage collector. It uses, currently it uses Boehm conservative garbage collector, which is okay. You can use stack allocations, which are, well, fast as it can be. And native calls are easy and cheap. It has quite interesting architecture, meaning that it's not only a Scala compiler plugin, but it compiles for both Scala C and Dotty into this native intermediate representation, which is quite close to LLVM, and then a native compiler that generates LL files. I'm gonna show you an example. So there is a code for some ray tracing algorithm. So we can run it. It's gonna compile it. Generated all these object files, all that stuff, and it generates a picture. Let's take a look at code. So we have this annotation struct. That means that this is not going to be a class, but it's going to be represented as a structure with these fields. It's going to be aligned in memory for fitting into caches, so all that stuff, which is good. Also, it has this extern annotation, which is actually your easy and simple way to call external functions. Okay. And otherwise it's normal Scala code. You can do almost anything. 1 second. Almost forgot. This function radians called many million times and uses stack allocation for double and int. Without it, if we use garbage collection here, it's going to reduce performance drastically, because stack allocations are extremely cheap. So it generated a picture somewhere. Yeah. There are 2 spheres. So it works. Okay, that's it about Scala Native. And finally 2 words about ScalaMeta. So this tasty thing was originally developed as part of ScalaMeta. They allow, so the life before, so I started working. Hello? I started working on this Scala library when the first access to Scala Reflect macroses were given. So it used to look like this. So we have a Scala AST for while loop. It looks like this. Awful. So later, when quasi-quotes were implemented, who knows what quasi-quotes is? So it looks like this. So you write kind of Scala code in a quasi-string interpolator, and it matches this string to an AST, which is very helpful. So these matrices are deprecated, and these are not. Into words, there is a new, very beautiful and good API for ScalaMeta for example, parsing Scala code, which leaves commands and all the information of original tree. That gives an ability for many tools to do magical things. There are inline and meta macros for kind of replacing the old one. Tooling and IntelliJ support, there are guys who already told about that, and Zhenya is going to talk about it too. So, just to give you an intuition, there is a macro annotation called main that generates a main method for an object. It's that easy to implement. So if you try to implement Scala or Java annotation processors, have you? Not fun, right? So this one is much better solution, I believe. So that's pretty much it. Thank you. If you have questions, please ask.
Do you know what was the reason to add static fields when we have standalone objects?
Yeah. First of all, standalone objects, as I already told, don't generate static fields. Those are just implicit instances of a class with fields and methods. And some APIs, some probably reflection-based mostly, Java APIs want some fields to be static and some methods to be static. Also, static methods mostly faster because they don't do virtual calls.
So that's done specifically for Java interpolator.
Yeah, mostly. Well, if I'm not mistaken, just correct me if I'm wrong. But as far as I know, that's mostly for that reason.
A year ago I heard that there were same problems with the collections you spoke about earlier. Is there any success there?
Well, I've told that there are 4 or maybe even 6 kind of proposals for new design for collections, which probably should simplify things a bit. But as Martin told, they are not going to break compatibility that much. So I believe most of the API is going to stand there as it is. Maybe the implementation is going to be cleaner. Maybe breakout things gonna be evicted, or maybe can build from, can be or will be changed. I'm not sure yet. They don't know it either.
Still don't know.
So are we going to have any macro-based stuff optimizing collections? Because there were libraries like Scalaxy, and then they were deprecated because...
ScalaBlitz, I believe, right?
Yes, Scalaxy and ScalaBlitz, and then there was took another job and didn't have time, but it's a constant performance problem and memory problem.
The ScalaBlitz was work of Dima Petrashka and Denis Pomosha, no? Dima Petrashka did a good part of this, and he's now working on Dotty. So probably if someone else gonna take their job, probably, but I'm not aware of any such things. No.
Okay, one more question from me. Also, a year ago, Dmitry Petrashko was talking about the Dotty Linker, that the problem was in standard library. They wanted to reduce the amount of code in standard library according to the code you are using in your application. They were using, correct me if I'm wrong, that data-oriented graph button to see what code are you use and remove that from the standard library. If it's working in the same way now, or they have changed the approach.
I'm not aware of kind of any huge differences in progress. Maybe Zhenya know, but I don't. Hopefully they complete this work, because it's very exciting. Sounds very cool, at least.
My question is about union and intersection types. You said that they become commutative in Dotty. So it is basically the replacement of this sequence of with. How they can be commutative if some methods are defined in different traits?
Okay, I'm not sure, but I believe those features are gonna add, not remove with, but add. How it's gonna be represented in the bytecode, I'm not sure.
But types become intersection or union types if we describe type. If we describe some method in both one type, another type, and then use that end or notation to mix this in single type. Now we have strict linearization rule. We go left to right, we inject what is not yet injected, and if there are def x and def x.
I'm sorry, I can't answer that, I don't know. No questions? Okay, thank you.
Scala is a wonderful language. It combines almost like most of the techniques exist in language design. So if you know language, Scala language, probably you know like 90% of everything, which is maybe beneficial.